I wanted to go over some problems from your review today since I didn't get to see some of you guys. On the second page, I give you a linear equation in standard form, and I'm asking you to find the two intercepts and then to fill in the table of values. Okay, so my x-intercept would be this, and my y-intercept would be this. Okay, remember that we said that when we're looking for the x-intercept, it'll be a point on a line that touches the x-axis. And remember that any point on that x-axis will have a y of 0. So with confidence, when I'm solving for the x-intercept using my function here, I can make the y be 0 because I know that when it crosses the x-axis, that x-intercept will have a y of 0. So I already know that this can be zeroed out. So when I'm solving for the x-intercept, I'm going to solve for x and make the y 0. Okay, you can also make this into a mixed number if you like. So if you're going to graph a point, remember this is the x, so this would go here, and we made y be 0. So negative 15 over 4 over there. When I'm doing the y-intercept, I follow the same process. But I remember that any point on a line, on a coordinate point, if I'm graphing the y-intercept, okay, that point will have an x of 0 when it crosses the y-axis. Any point on the y-axis has an x of 0 by definition. So that means with confidence, I know that if I'm solving for the y-intercept, I can make x be 0. And then I'll solve the rest. And I'll get negative 3. If I want that in a coordinate point, I just solve for the y, so that would go there, and I made x be 0. Okay, so that we had gone over in class. I don't think we went over the other stuff too much, but here I want to know when x is 5, what is the y value in this same equation? So very simple, I can start just like we were evaluating functions before. I start with my function, but this time I want to make x be 5 and find out what the y would be when x is 5. So I'm going to substitute in the 5 for the x so that I can find out what that y value is when x is 5 in this function. And you just solve normal, like a regular equation that we have practiced many times. So y would be negative 7. So when x is 5 in this function, y is negative 7. Okay. The other one is asking me, well, what if I give you the y value? When y is 1, what is the x in this function? Okay, so we'll do the same deal. We'll copy the function. This time, I want to know that when y is 1, what would be the x? So I will substitute in the value of y with 1, so I can know what that x would be when y is 1. And then we solve our equation, as usual. Get negative 5. So when y is 1 in this function, x is negative 5. When y is 1, x is negative 5. Okay, so that's that one. I'm going to skip back to the page and talk about these. First of all, some of you, so the last one I'm going to do first, that letter F, I change this to g of 3 of x squared, because we haven't talked about quadratics yet. To make it too complicated by leaving F. I gave you the functions at the top that you would use for. So I'm going to start with that one again. I changed the okay. Here I know that I am evaluating g of x, or g of 3x, and then after I'm done I have to. So I'm going to do this first. What is g? I'm going to start by writing the original. G of x equals 4x. And remember that instead of x, I switched it to 3x. Okay, so instead of the x, now I'm going to switch that to 3x. And simplify. So then I just multiply it. Here I got 12x. Now that, remember that I have to square it. These, I have to square. That means power of 2 and x to the power of 2. So as if I rewrite it like this. This is what that means. Squaring means that you multiply that number by itself 2 times. So that's 144x squared. That would be the answer for F. I'm going to go back and do letter C. Letter C tells me to evaluate f of 3 minus g of 7. First, let me evaluate f of 3. So I write my original equation. F of x is 2x minus 1. But this time, instead of x, they want 3. So instead of x, I'm going to change and then simplify. So that gives, okay. So now they want me to evaluate g of 7. So instead of x, I'm going to have 7. So I'm going to do it here, original equation. And instead of x, 7, evaluate for 7. And that will be that. Now with those two values, subtract. So 5 minus 28, it'll give me negative 23. And that will be my answer. Do D and E as well. Over here, D, also a little more complex, but they want you to evaluate f of 2x. And then when you're done, they want you to multiply it by a negative 1. Remember, we don't see 1. So I'm going to do this first. So I'll write my original equation, which is minus 1. But instead of x, they want me to evaluate for f of 2x. So instead of x, I am going to write 2x. And I'm not done yet. With that, they want me to or multiply it times a negative 1. So I will multiply a negative 1. Here you would have to distribute. So whether you do the arrows or you do it in your mind or you do the distributive property box that we practiced in class and multiply. 1 times 4x, negative 4x, negative 1 times negative 1, positive 1. So the answer would be that. Once it's simplified, this is what you get. Let me go over E. E, a lot of things are happening as well. So 2 times all of this. So I'm going to do the parentheses first, and I'm going to evaluate g of x plus 4. So I will write my original equation of g of x, which is this. But instead of x, I want me to do x plus 4. Instead of x, I'm going to do x plus 4. Here it looks like I have to distribute, so with arrows in your mind, you multiply, or you can do the box to distribute. 4 times x, 4x, 4 times 4, positive 16. Okay? Once that I'm done with that, I'm not done. I have to multiply all of that by 2. So all of that by 2. So I need to distribute one more time. 2 times 4x, or like this, however you do it, would be 8x, and 2 times 16 is 32. And that would be my final answer. Okay? For the last part, I'm going to go over the car problem over